Hello everyone, I welcome you all to this course Certification in Quantity Surveying, and we are calculating the reinforcement details of various components. So let us start with the first and simple component, that's the foundation bar bending schedule for the footing. First of all, let us understand what is the drawing given, and based on that drawing how am I going to calculate the bar bending schedule for the footing, because BBS is a very important this documentation in a construction, because reinforcement is a heavy and costly material, and that BBS has to be perfect so that whatever the reinforcement you are utilizing is not consuming surplus amount of money. For that we need to have focus of very minute detailings about this BBS. So the diagram given as a foundation plan, it's isolated footing with the dimensions 1150 mm to the 1150 mm. It's a square footing. Then it has an reinforcement jali. We call it a jali. That's a need reinforcement as a top and bottom bars. Both of the bars are of 12 mm dia, whose spacing is at 150 mm center to center. So distance between these two bars, vertical or horizontal any, they are placed at 150 mm and are of diameter 12 mm. And that has been the section provides the detail about the thickness of that foundation, that is a 300 mm, and the cover that is provided is a 50 mm from all the sides. All the side includes 50 mm from top, side and bottom, everything. So let us see how we are going to calculate first of all number of bars, then length of the bar, and ultimately the BBS document. So first we need to calculate the number of bars. So as the total length over the length from both the sides means x side and y side it's same, so we are going to calculate the number of bars for once only. If we want to calculate for the number of bars for the x axis, we are going to use the effective length of the y axis. That is essential. And if we are calculating the number of bars for the y axis, we are going to use the effective length of the x axis. As I have already told you in an interactive part, just to revise it, if I want to calculate number of this, so to whom they are serving, that means to whom they are perpendicular, is a horizontal one. So when I want to calculate the number of bars on a y-axis or vertical ones, I use the effective length on the horizontal one. Okay, so the formula we have is the number of bars is equal to effective length on the opposite side divided by spacing plus 1. Then what exactly is the effective length? That is another important one. That is equal to the total length minus cover from both the sides. Now, so let's calculate the effective length first. That is effective length is equal to total length, that is 1150 mm, minus 2 into cover. So cover is provided to be 50 mm. So minus 50 and minus 50 from both the sides means from this side and from this side for vertical, from this side and from this side for the horizontal ones. So the effective length comes out to be 1050 mm for both the sides, as it is the same one. If it was different, I would have gone for different calculation of effective length for y-axis, effective length for x-axis, or effective length horizontal, effective length vertical, based on that. Okay, so for now our effective length for both the sides is 1050 mm. Now, as I already told you, tip, I have focused on this one more, because many times people do go on a confusion that whatever the length they are serving, they go on using that effective length only, which is totally wrong. So we need to use, to calculate the number of length bars for horizontal axis, we use the effective length of vertical axis, so and vice versa. So while calculating number of bars for the horizontal direction, consider the vertical length as the effective length, that is number of bars in each direction. Now why I have said on each direction, because our length is same on both directions. So that is 1050 effective length divided by spacing, that is 150, which is given over here. Both the bars are spaced at 150 mm center to center, plus 1, that is 8. So there are in total 8 bar horizontal and 8 bars vertical, and there provide a grid is been made, a jali, a net is been made, so as the load transfer will take place from column to foundation to soil. So now let us calculate the cutting length in a x direction. As the bars and length is same, it is going to be same, but let us calculate one by one differently. So cutting length of a bar in a x direction. So the formula for that is the effective length that we have calculated minus plus bends, whatever the bends that we are going to give. As bends here, if you are able to see, These are the two bends which are of value. 90-degree bends are provided. Then the bend deduction for that 90-degree bend, what is the bend deduction we are going to have over here, that we need to minus only. Okay, so what is first of all, let us elaborate that formula more. Effective length, that is as it is we are going to use, plus how many bends are 90-degree bends are there, 1 and 2 90-degree bends are there, so plus 2 into, now what will be the length of this one, that this member's length we need to calculate, as it is a separate member than the effective length, right? So for this one I need to consider first the outer dimensions of the foundation. Now whenever this foundation's outer dimensions I need to minus, from that I need to minus the covers from both the sides, from top and from bottom. When I'm going to minus the cover, as if you are able to see, this is what the length of the bar is. If up to here we know it's the effective length, from here above I need to calculate the length, and for that we need to minus cover from this side and from this side. If I minus the cover, I get this length, that is equal to foundation depth, that's the total foundation depth, which is 300 mm, minus cover from top and cover from bottom, both, minus the bend deduction. How many bends of 90-degree we have is a 1 from this side and 1 from this side, so 2 into bend deduction for 90-degree. So now let us put the values. Effective length we have 1050 into plus 2 into 300 is a total foundation depth, out of which cover from 50 from top and cover from 50 or bottom, minus 2 into 2d. 2 into 2d is a 2d is a uh, over here 90-degree bends value, that's we are going to minus, and 2 is from the two 90-degree bends, 1 and 2 90-degree bends. So total value comes out to be 1402. Now for x direction as well as y direction, there is a effective length is same and everything is same. So we are going to get the same value as it is for the y direction also, that is the 1402 mm. Now the most important, we most of the times on a site do it on Excel. For your explanation I put it into this format, but in Excel it is much friendly and easier, as you directly go on putting the values and you just go on get the total weight or length and anything. So for our understanding I have put it into this format. So bar bending schedule document, it's kind of this one, where it is it has a serial number, then type of bar we have, what is the shape of bar, then the bar's diameter, then the number of bars that we have calculated, the cutting length for one bar we have calculated, total cutting length by multiplication of the number of bars in cutting length, and the unit weight of bar that we are going to remember by heart, or we need to calculate it by d square upon 162 value, then the total weight by multiplication of the unit weight of bar to the total length of the bar. Okay, so for x-axis we have shape of the bar is to be the U shape. Okay, then the dia of bar is a 12 mm, which is given over here, it's a 12 mm bar dia. Then the number of bars we have calculated is a 8 from both the directions. So for both the direction I'm going to put 12 as a dia and 8 as a number of bars. Then the cutting length for 1 in meter, so we have calculated cutting, this length is 1.402 meters, which is put over here. For both of them is same, and the total length is coming to be, for this I'm going to multiply this 1.402 to the number of bar, that is 8. So number of bars into cutting length of one bar, it comes out to be cutting length for whole x direction. Same is with the y direction. What is the unit weight of bar? D square upon 162, that comes to be 12 divided by 12 upon 162, the value comes out to be 0.889, and this is what you need to remember always. Then we are going to multiply for total weight, we are going to multiply this unit weight of one bar to the total length in meter. So I'm going to get this values in a kg as an reinforcement. I just going to sum them to get the total reinforcement for that footing. Now I'm going to add the wastage of 3% to 5%, as we whenever we I just as we I have told you 12-meter bar if coming on a side, there is some wastage of that bar always goes some if the whenever we we take precautions always, but certain situations we go on wasting them. So that wastage I'm going to add, and the total steel that I'm going to need for this footing is 20.54 kg. Now this is a very simple illustration of the reinforcement calculation for the footing, which is a simple, and both dimensions same. We'll be doing it more complex as and when we are going to face it. So with this, I wish you all the best. Thank you so much.